We just looked at how to solve linear equations in one variable, and this is going to be more great practice, but in this case we're going to end up with solutions that are a little bit different. So again, I'm going to work through these with you. If you want some good practice, you can always press pause and work through them without me till you get to the end, and then we'll talk about what those solutions mean. So here, I'm going to keep my -1. I'm going to distribute my 5. On the right side, I can go ahead and combine like terms on this step if I want to, or since I have to do it on the left side on the next step anyway, I can just wait. But again, notice I'm showing each line. On the next line, I'm going to combine -1 and -10, so 5d minus 11. And I'm going to combine 12d and minus 7d to get 5d plus 3. Now you might notice that we have a 5d on each side, but let's go ahead and follow the instructions we did on the last video, which is to get the d's to one side first, all of the variables. So I'm going to subtract 5d, and when I do that, notice something different happens. I just get -11 on the left side, and on the right side I get 3. So obviously this is different because all of our variables are gone. So when we have a special case equation, that's when the variables are going to go away. Now in this case, I'm left with an answer that is false because -11 obviously does not equal 3. So when we do this and we get something that is false, our final solution is that there is no solution. You might also see this written as the empty set sign. Now let's look at our next example, which, if I remember correctly, is the other special case type of equation. So again, I'm going to follow the same steps that I have been following. I'm going to distribute 7k plus 28 minus 10. And on the right side, again, I could simplify, or as I'm going to do, I'm going to wait until the next step and just simplify each side at the same time. So here I'm going to combine these two to get 7k plus 18. And on this one, I'm combining to get 7k and adding those two to get plus 18. Now notice, I'm in the same situation I was right here where I have the same variable and value on each side. But now when I subtract 7k from each side, I end up with 18 equals 18, which of course is true. 18 does equal 18. So when all of your variables go away and you end up with a true statement, the solution is all real numbers, which means I could take any number I want, plug it in for k, and each side of that equation would be true. You might also see this written as the R for all real numbers. So here are two for you to try for good practice. So press pause, try them both, then press play to check your work. So for my first one, I'm going to distribute the 2x minus 6 equals, and then again I can go ahead and combine those on the first step if I want, which I'm going to on this step. So I get 2x minus 6 equals 2x plus 17. When I subtract 2x from each side, and that's of course why I ask you to do the variables first, I get -6 equals 17, which is false. That gives me a no solution. And my second, I don't have to do any distributive property on this one, but I do combine these two. 3x minus 2x gives me x minus 12. And notice, I threw this one in to make sure you were paying attention. This is not a special case equation. I end up with 4x equals -12, so x equals -3 by dividing by 4. So don't just assume they're going to be special case equations. This is what we ended up with on this time, is just one solution.